And good afternoon, everyone. Thanks for jumping on. This is another ATS University session. This one focused on product sustainability. We've got one of ATS's many partners, but one of our covering some of the most categories on our spec tool, I think, is Watts. So talking about product sustainability today for all those various categories that Watts covers, from backflow to ACVs, PRVs, drains, et cetera, et cetera. We've got our partner Vaz, who's a product sustainability engineer. So thanks for joining us today, Vaz.
Yeah, thanks for having me.
I know this is going to be a great discussion, but before we pass it over to you, a couple bits of housekeeping. For anyone that is maybe unaware and somehow jumped on this for your first time, thanks for trying out the ATS University. We do these on a near weekly basis, usually about 3 a month, covering various products, and topics in the industry. Everything from barrier-free code to how to size certain types of products, and a lot of application-based discussions where we talk about getting the right product in the right application. That mantra has really been a foundation of ATS and our product specification tool, which is available at atspec.com since before the originations of the website, back when we were a paper manual. But we've followed sustainability path and effectiveness and moved online many years ago, continuing to update and change things and improve things as we go. But to this day, we do still have our product spec tool, which will still help you choose the right product for the right application, and make sure simple things like getting the barrier-free code for your local region are taken care of. So if you need any help with getting your firm set up on that ATS spec tool, that's where my team comes in. I'm the market development manager for our teams across Canada and the US. And our team will help get things like training for your staff, or help get your individual firm's masters built online for you, so that you have even more effectiveness on the system. I see a number of names on there that I know already have their masters set up with me and have been recurring guests to our ATS University. So thanks to you for once again attending. But yeah, I guess without any further ado, I'll pass it over to you. With one last bit of housekeeping, we do have this recorded, so it'll be available on our ATS University session of the website. So if you want to watch the recording or check out any of our previous recordings, that's also hosted there. And of course, with all of our ATS University sessions, we do send out a certificate of attendance on Friday for any of those that need to self-report. Then there's a generic certificate for you to include in your documentation. But I believe this is an accredited CEU as well, right, Vaz?
Yeah.
So you'll cover how they can report for that, right?
Yeah, actually, Brian's been handling the logistics of that one. So if I don't talk about it now, I can at least email everyone afterwards.
Yeah, we'll make sure that if there's any sort of number or anything like that, you guys have that for your reporting purposes. Well, I guess without any further ado, I'll pass it over to you.
All right. Yeah. Thanks a lot, Zach. Yeah, like Zach mentioned, my name is Voss. I'm a product sustainability engineer for Watts Water. I got a presentation on product sustainability today. I'm not sure if my email's in the invite, but if not, I'll send it out. So please reach out, afterwards if you have any questions or want to learn more about anything I covered. This is kind of like a high level presentation. I'm covering a lot of different topics. And if you're interested in learning more, please reach out. Always happy to talk more about it. So yeah, as everyone knows, sustainability has become an important topic over the past few years and will continue to grow in importance. Customers, companies, and investors are all starting to place more significance on sustainability. So it's really important that we educate ourselves around sustainability. So during today's session, we'll go over some key terms around sustainability, talk about the circular economy and its benefits, talk about life cycle thinking and life cycle assessments, or LCAs, review green building certifications, and then do a deep dive into designing for sustainability. And if anyone has any questions, just feel free to throw it in the chat, and we'll address them as they come up. So first, let's review some key sustainability terms. The first one is just sustainability. So there's a lot of buzzwords thrown around when talking about sustainability, but at the end of the day, It's really just about being able to meet current needs without compromising the ability for future generations to meet their needs. So when thinking about sustainability at a company, it's really about balancing three things: people, planet, and profits. So people focuses on an organization's commitment to positively impacting society. Profit focuses on the financial return an organization generates for its shareholders. And the planet focuses on the organization's effect on the environment. So this is known as the triple bottom line of sustainability. And in today's session, we'll really focus on planet or environmental sustainability. And at many times at a company, sustainability is discussed in two terms: footprint and handprint. So footprint measures the negative impacts that an organization has on the environment, where handprint focuses on the sum of positive impacts an organization can take to better the planet. So understanding these terms kind of helps improve communication around sustainability, and you'll know what companies are talking about when they talk about footprint versus handprint. Another big term that is around sustainability is the circular economy. So I want to talk about the circular economy versus the linear economy. So a linear economy is mostly what occurs today and how things have been done for a long time. So it's where products are made with materials taken from the environment, used, then discarded. It's known as the take, make, waste model. One step better is the recycling economy. But this isn't perfectly circular because many times materials are downcycled due to contamination in the recycling streams, or materials won't be recycled at all due to lack of profitability. The best case scenario, and where we should be moving towards, is a circular economy. In a circular economy, waste doesn't exist because it is used as the raw material for future products. The next slide has a video showcasing the benefits of a circular economy. The video was created by the Ellen MacArthur Foundation, and their foundation committed to developing and promoting the idea of a circular economy. So I definitely recommend visiting their website if you're interested in learning more. Hopefully the video isn't too laggy, but I can also throw a link. It's on YouTube, so it's a little laggy now. I'll put a link so people can watch it afterwards.
Living systems have been around for a few billion years and will be around for many more. In the living world, there's no landfill. Instead, materials flow. One species' waste is another's food. Energy is provided by the sun. Things grow, then die, and nutrients return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components and the packaging they come in, we can create safe and compostable materials that help grow more stuff. As they say in the movies, no resources have been lost in the making of this material. So what about the washing machines, mobile phones, fridges? We know they don't biodegrade. Here, we're talking about another sort of rethink, a way to cycle valuable metals, polymers, and alloys so they maintain their quality and continue to be useful beyond the shelf life of individual products. What if the goods of today became the resources of tomorrow? It makes commercial sense. Instead of the throw away and replace culture we've become used to, we'd adopt a return and renew one, where products and components are designed to be disassembled and regenerated. One solution may be to rethink the way we view ownership. What if we never actually owned our technologies? We simply licensed them from the manufacturers. Now, let's put these two cycles together. Imagine if we could design products to come back to their makers, their technical materials being reused and their biological parts increasing agricultural value. And imagine that these products are made and transported using renewable energy. Here we have a model that builds prosperity long term. And the good news is there are already companies out there who are beginning to adopt this way of working. But the circular economy isn't about one manufacturer changing one product. It's about all the interconnecting companies that form our infrastructure and economy coming together. It's about energy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons. Instead of remaining trapped in the frustrations of the present, with creativity and innovation, we really can rethink and redesign our future.
All right, so yeah, it's a cool little video. Definitely, you know, a lot to think about. But I think the main point of that video is to really try to rethink waste and try to, you know, not think of waste as something that just goes to a landfill and disappears, but really try to get creative and find ways to turn waste into new products and new raw materials. And I'll definitely talk a little bit more later about some techniques that can get us to circularity. All right. Okay, cool. So next I wanted to talk really quickly about green building certifications. So as companies are looking to be more sustainable, green building certifications are growing rapidly. These rating systems evaluate the sustainability of the design and construction of new buildings. There are many different certifications as shown at the bottom, but they all focus on creating efficient, environmentally friendly buildings through focusing on water conservation, energy efficiency, responsible material use, and designing for human health. The most widely used green building certification, and probably the one, if you've heard of any, the one that you've heard of, is LEED. So it's a holistic rating system that takes into account a variety of sustainability aspects. Buildings earn points by getting credits within certain credit categories that we'll go over in the next slide. There are various levels of LEED from certified all the way to platinum. So how can a product support a LEED green building project? So from a product design standpoint, products themselves don't actually earn LEED points, but they can be designed with the LEED credit categories in mind so that the use of the product will give the building more LEED points. So this is a great way to increase the likelihood of a product being included in the BOM of a green building project. So LEED credit categories are location and transportation, which focuses on the location of the building and how easy it is to get around through walking and public transportation, water efficiency, sustainable material and resource use, innovation, which is an open category for any new or innovative sustainability technologies, sustainable sites, which focuses on protecting or restoring the habitat where the building's located, energy and atmosphere, which is around efficient energy usage, indoor environmental quality, which is, focuses on indoor quality and health of the occupants. And then lastly, regional priority, which focuses on designing the building sustainably based on the region the building is. For example, a sustainable building in Phoenix, Arizona is not going to look at all like a sustainable building in Buffalo, New York. So you really got to think of, regional priority. And that's one of the things LEED highlights. So more specifically around products and product design, this is the LEED V4 materials reporting form. So the more questions you can answer yes or provide a value here, the more potential LEED points your product can help the building earn. So I won't go over everything in here, but some of the ones that kind of stand out are EPDs, environmental product declarations, LCAs, life cycle assessments, which I'll talk about in a sec, recycled materials, and material health disclosure. So I definitely recommend finding this form on the US Green Building Council. If you're looking into designing products to support LEED projects, this kind of helps you focus, know where to focus on for this product design. All right, so now before we talk about design for sustainability, I want to quickly touch on the product lifecycle and LCAs, or lifecycle assessments. So the product lifecycle consists of 5 stages. Raw materials, which includes the extraction and processing of raw materials. Manufacturing, which includes all steps to convert that raw material into a finished good, inclusive of packaging. Distribution, from the manufacturer to the retailer and then to the end user. Use, which covers any impacts where the user is in possession of the products, including, water usage or energy usage. And then finally, end of life, which covers anything from landfilling to incineration, to either recycling or recovery of the material. And what a life cycle assessment is, or an LCA, it takes that a step further, and it's a way to quantify the environmental impacts of a product throughout its life cycle. So it does this by taking into account the energy and material going into the product, as well as the emissions and waste going out of the product at each stage of the life cycle. So it's a really helpful tool for holistically understanding the environmental impacts of a product, and also helps weigh trade-offs when making design decisions. All right, so I know I kind of covered a lot there, but those were kind of just some key terms around sustainability that are good to know. Zach, are there any questions in the chat before I kind of get into design for sustainability?
None that I see coming in so far.
Perfect.
Yeah.
All right, sounds good. Well then, yeah, we'll keep moving on to design for sustainability. So there's many methods and techniques around design for sustainability. I'll go over a couple of key things to consider when designing for sustainability, but keep in mind an ideal approach will utilize a combination of these techniques depending on the situation. So the first one I want to cover is life cycle thinking. So whenever thinking about design for sustainability, it's essential to employ life cycle thinking. This is a framework that considers the environmental impacts throughout an entire life cycle. So it's important because it expands the thought process of the designer and helps weigh trade-offs of design decisions. Typically, designers are really quick to focus on raw materials or end of life, but many times the largest impacts occur during the use phase. So make sure to take into account all stages of a product life cycle when designing for sustainability in order to have a holistic solution. And I'll go over in a sec, kind of how we can think about sustainability at each of these stages. But one of the best ways to design for sustainability and, employ life cycle thinking is actually to integrate LCAs, or life cycle assessments, into the design process. So it's a great way to have design decisions backed by scientifically proven methods and to fully understand trade-offs. So many companies have LCA programs or tools, or starting to ramp up their LCA programs. So definitely reach out to your sustainability team to see if this is something that they might have. If not, it's also an important thing to keep asking about, because companies are going to start implementing LCAs in the next couple of years. So it's always better to kind of get ahead of these things than to be behind and chasing it. So yeah, definitely ask your sustainability team about LCAs. And even if you don't have LCA capabilities, remember to always utilize lifecycle thinking during the design phase. Take a little sip of water before I keep going. All right, so first let's talk about the first stage of the product life cycle, which is raw materials. So using unsustainable materials can harm the environment, deplete natural resources, and contribute to climate change. By adopting sustainable material usage practices, you can reduce your waste and conserve resources. So what are sustainable materials? Sustainable materials can be renewable, recyclable, biodegradable, and are non-toxic. Keep in mind that there's no such thing as a perfectly sustainable material. All materials have their environmental benefits and their drawbacks. So it's really the use of the material that makes it sustainable. So always make sure that products are designed for long life and are durable, so you can get the most out of those materials that you're using. Some examples of sustainable materials are renewable materials such as bamboo, cork, and hemp, recycled plastics, and then metal or glass with high recycled content.
I think one of the interesting things that you're kind of going over here is like when you think of sustainable materials, to me, it almost always goes to that first bullet. You know, products that are renewable, growing on their own. That's kind of what comes to mind. But you know, it's an interesting concept of going back to metal that's going to be reused or has already been reused in formation of something. You know, that kind of the what do you call it, the circular.
Circular economy, circularity. Yep.
That's an interesting concept.
Yeah, no, it definitely is. Because I mean, obviously, in a ideal world, you would try to use renewable materials for everything. But I had a joke in my old company: you can't really make a baby seat out of glass. You can't really make it out of wood. So sometimes you do have to use plastics, and it's not a bad thing. It's really about how you use the material and what kind of materials you choose that makes it sustainable. And then while on the topic of materials, wanted to quickly go over the difference between recycled content versus recyclability, because this can be a confusing topic. So recycled content refers to the amount or percentage of recycled or recovered material used in a product, whereas recyclability is about the ability for the product to be recycled at its end of life. So just kind of a quick important distinction to understand when talking about materials versus end of life. So some best practices for implementing sustainable materials are to partner with material suppliers that are committed to sustainability. This is extremely important. Really talk to your material supplier about sustainability because they can be a great partner to work with. Choosing obviously sustainable materials that meet performance, cost, and quality requirements. Some people always say that sustainable materials are more expensive. But many times with the recycled material, they actually cost neutral. And then lastly, designing products that are durable, repairable, and recyclable to keep those materials in use for as long as possible. And we'll go over that last bullet in a lot more detail. So yeah, like I mentioned earlier, designers and engineers tend to focus on raw materials and end of life when designing for sustainability, when use phase can be overlooked. But it's a really important stage to consider because a lot of times it's actually where the largest impacts occur. So I wanted to go over some design for sustainability techniques for the use phase. You can probably notice I skipped over manufacturing and distribution. These are obviously important too, but those are typically handled by operations and supply chain. So won't cover them in this session. But definitely still something important to think about when you're thinking about sustainability, and important to work with your operations team around manufacturing and then your supply chain team around distribution. But yeah, I'll go over some design for use phase sustainability techniques. So one way to positively affect the use phase is to design for R. This refers to designing for reuse, repair, remanufacturing, and recycling. So design for R helps close the loop and move towards a circular economy. It also ensures we get the most out of the precious raw materials and resources that go into a product. So when designing for R, always follow the inertia principle shown on the left. So don't repair what's not broken. Don't remanufacture something that can be repaired. Don't recycle a product that can be remanufactured. And always only replace or treat the smallest possible part. So remember, the smaller the loop in the diagram, the smaller the environmental impacts that occur. So you always want to have the smallest loop to be the most sustainable. So let's first talk about the smallest loop, which is reuse. So reuse saves resources by keeping existing products in use for longer. The goal for reuse is to keep products functional for as long as possible. So when thinking about reuse and designing for reuse, consider the following things. The durability of the material and all connections, ease of cleaning, maintenance, and repair for the customer, standardization of screws and fasteners, and finally, product attachment and trust. Remember, products don't only get discarded when they break, but also for technical obsolescence or fashion changes. So always always ensure you're being sustainable when designing for reuse, because there can be trade-offs. So typically reusable products need to be made with more material than disposable ones. So ensure the product can last many reuse cycles. So the more reuse cycles a product can go through, the higher its environmental advantage over a non-reusable alternative. So some key examples of designing for reuse could be, a reusable or refillable canister for a filtration system compared to a disposable one, or a cleanable screen for, a strainer in a plumbing system versus a disposable one. By making something reusable, refillable, easily cleanable, you can really avoid disposables. The second smallest loop is designing for repair. So there are many benefits for designing for repair, both for the consumer and the company. So companies can benefit from design for repair by offering repair services, selling spare part kits, and differentiating their product from competitors. Also in many areas, especially in Europe, right to repair laws are being implemented, which actually require specific products to be repairable. So these are definitely starting to grow into different industries. So when designing for repair, here are a couple things to keep in mind. You want to make sure all parts of the product are easy to access with minimal tools and glue. So it's important with minimal tools needed. So it's important to avoid glue as a fastener, because sometimes that makes it hard to get to internal components. Having standard screw types and an easy way to open the product is important too, along with having good documentation and repair instructions. Lastly, if a product is really complex, designing it in modules is a great way to create simple repair. So for example, in a smartphone, having a replaceable camera or battery module allows the user to just replace that specific module when it breaks without having to replace the whole phone. So designing for repair is sustainable because it keeps the product in use for as long as possible while avoiding waste and new product creation. Keep in mind, repair does become less sustainable when a product becomes obsolete if a new product has, more efficient energy or water usage. So something to keep in mind if a product is, using energy or water. A good example for designing for repair would be a pressure reducing valve with replaceable parts for their internal components. So you can see on the top right, the external shell is made from really durable metals, but on the bottom right, the internal springs and gaskets are far less durable and typically what will break first. So having replacement parts and easy repair instructions for these components ensure that the product stays in use for as long as possible. And just because one spring breaks, you don't have to replace the whole valve body and throw away all the metal and the other valuable materials within it. So the next loop in the design for our techniques is remanufacturing. So the goal of remanufacturing is to create products in an as-new condition. This is done by collecting used products, sorting, cleaning, repairing them, and combining them with new parts to sell as new. It's important to keep as much of the value already put into the product, so reuse as many of the old components as possible. Also, when thinking about remanufacturing, it's important not just to retroactively think about remanufacturing, but also think about how to design future products for remanufacturing.
So a question came up around the idea of remanufacturing here, and they're curious whether a recycled, can a recyclable material or product at the end of its life cycle then be recycled and remanufactured? And then if so, are there going to be like levels and stages of recyclable or remanufactured products?
Yeah, no, that's a good question.
Use like 2 times, 3 times, whatever it is.
Yeah. So I'll touch on that a little bit more later, but it's definitely always important to design for recyclability while also designing for remanufacturing. because at some point, some of the components are going to break and not be able to be used again. So it's really important to, design for recycling as well. So they kind of go hand in hand, where you'd prefer reusing and remanufacturing as many components as possible. But sometimes at the end of the day, you do have to go to recycling. Yeah, good question. So why design for recycling? There's barriers and drivers around designing for remanufacturing. So some of the drivers are sustainability. Companies can take care of the resources already put into products. Profitability, allows companies to create products that can be manufactured for much less, a lower price point. So it has benefits where companies can offer like new products for cheaper and actually get into potentially new market areas that require lower price points. And then, like we mentioned earlier, around the circular economy, it allows companies to create products which fit into a circular economy, which is becoming an increasingly common ask from customers. But I will say, designing for remanufacturing, it's complex and there are some barriers. So some of the barriers a company could face or market cannibalization. They could see selling remanufactured products as cannibalizing new ones. There also can be logistical difficulties, as keeping track of products made multiple years ago can be difficult. And then another one is consumer perception. So some customers could think of a remanufactured process as used and of lesser quality. So definitely important to show that that's not the case. So when thinking about remanufacturing, you got to tailor a solution that works for your company, your customers, and the environment. It definitely takes a lot of problem solving, and it's a very cross-functional situation where you'll have to work with your supply chain team, as well as your design team, your engineers, and your manufacturing team if you want to have a successful remanufacturing program. So there's a lot to think about, like I kind of just alluded to, a lot to think about when designing for remanufacturing. Here are a couple of the main points. So you really need to have good documentation around the product so that, all components are easy to identify, and it's easy to diagnose what must be done to give the product a second life. You also should use durable materials that can last multiple life cycles, and avoid chemicals that could potentially be banned later on. The product should be easy to disassemble and clean. So use standard screw types and fasteners and try to avoid glues, welds, or rivets. Like I mentioned earlier, designing for modularity is helpful, and also a way to ensure that the product is upgradable, which is really important to kind of keep it in use for as long as possible. Lastly, which, the question Zach just mentioned, and we'll talk about more in the next slide, you should always think to design for recycling in parallel with designing for remanufacturing, because at some point the components in the product will come to their end of life, and it's important that they can also be recycled if they can't be remanufactured. And as a bonus, if you're designing for remanufacturing, you're simultaneously designing for manufacturing, and you'll be achieving a more efficient and better manufacturing process as well. So finally, covering the last design for our technique, which is designing for recycling. So this is the final loop. It's the largest loop, but it's also the last chance to give materials a second life before they go to the landfill. So while reuse, repair, and remanufacturing are preferred methods, designing for recycling should always be considered along with those options. So how do you design for recycling? You obviously want to choose recyclable materials. A little hard to see, but on the bottom right is the amount of material recycled by material type in the US. One thing about recycling, it does vary a lot by region. So I'd recommend, depending what region you are, there's readily available statistics around recycling. But for the purpose of this presentation, I'll go over the US recycling stream. So as you can see, paper and paperboard or cardboard are recycled at extremely large volumes, so a very recyclable material. Metals are also recycled at very high volumes and infinitely recyclable. while all the other materials shown, including plastic, glass, and wood, are recycled at very small volumes. Like I mentioned earlier, it can vary by region and especially by country. So definitely research whatever region you plan on selling to, so that you can kind of you can choose materials with that region in mind. You'll also want to make sure that a product is made with a single material when possible, as this helps avoid contamination. Obviously, this isn't always feasible. So when it's not feasible, try to make sure that components can be easily separated and that there are recycling instructions so the consumer knows what can be recycled and what has to be landfilled. So those are all the design for recycling techniques, or design for R techniques. It's important to kind of use a combination of a couple of those.
I guess I'm out of the loop. I thought glass would have been higher.
Yeah. So in the US, unfortunately, not as much anymore. Before 2016, we used to send that to other countries to recycle and send back to us. But now, since we do single stream, it's hard to separate different colors of glass. So they all mix together and become a very dark, murky color of glass. So you can't get that clear glass, that transparent glass anymore of high quality. And so that's why typically glass is actually downcycled into road materials, construction materials, sand, that kind of stuff, and is rarely recycled back into glass.
Interesting.
Yeah. So a couple more other use phase considerations. So, another way to positively affect the use phase, which like we talked about earlier is kind of an important phase, is to design products to use minimal resources such as energy and water. Water specifically is becoming an increasingly precious resource. It's projected that the world will face a 40% global water deficit by 2030. So make sure to design products to have reduced water consumption or in ways where water can be cycled and reused. Designing for water conservation also helps give you an edge of the competition and helps your customers save money, which is always an important selling point. One example of this is Blücher's Hygienic Pro drainage system. So this uses almost 97% less water compared to traditional channel drains. So this can save a customer, especially if you're thinking about, like a food manufacturing plant, a countless amount of water over a couple of years, while also reducing the spend on both water bills and sewage bills. So, reduces customers' money spent in a couple different areas. So, thinking about water conservation has a multifaceted benefit, both on the sustainability point and from a monetary standpoint. And then another potentially huge impact in the use phase is energy usage. So high energy usage can lead to expensive bills for customers, because water is still a fairly cheap commodity, but electricity and natural gas is definitely not the case. So it can lead to expensive bills, and it definitely very much contributes to greenhouse gas emissions. The problem is typically worse in older products, which weren't designed with energy efficiency in mind. So one example of this is aging commercial boilers, which waste natural gas, emit high levels of greenhouse gases. So, a way to fix this issue is to design efficient boilers. So one example of this is the Airco Benchmark Platinum, which optimizes its hydronic system for maximum efficiency. So it can actually increase gas efficiency up to 9%, which led customers to avoid the use of over 100,000 metric tons of CO2 over the course of a year. So, especially when you're thinking about natural gas, it's really, really important to design for efficiency and reduced energy usage. So very important thing to keep in mind when designing for sustainability. So as you've seen, I know I covered a lot, and as you can see, there's a ton of different aspects of product sustainability and designing for sustainability. But overall, when designing a product, you got to think about what's important to yourself, your company, your customers, and the environment. So always come back to the triple bottom line of sustainability, which is people, planet, and profits. and always apply life cycle thinking to your design process, so you're holistically thinking about the product. And then lastly, I'll just leave you with this. Education is very important. Education around sustainability is very important. So thank you for taking the time to attend this session today. Please make sure to teach others within your organization and put into practice some of the things that were covered today. And yeah, please keep learning about sustainability and implementing the things you learn.
And on that front, as we close up this part of the presentation, wait to see if any questions come in from the chat. We've also got a couple of poll questions just to keep people on point. First one here, what is the smallest loop out of the design for our techniques? So far, we're looking real good. A lot of people paying attention, focusing in on the reuse aspect. So they kept common with you.
Good.
Launch this other one that you had coming in. What are the 5 stages of the product lifestyle cycle in LCA? This was an interesting one, and I did like your focus there on the use case of it. That is a part that I agree is often overlooked. And, I've done countless projects over the years where they are, maybe you do have someone looking at forward thinking, focusing on sustainability. They're concerned where the product's coming from. They're concerned about how it gets disposed of. But if it takes a ton of extra maintenance during the actual life cycle, those 22 years or 15 years, whatever it is you're planning on, and your maintenance is shooting up, your repair parts are shooting up, it's doing this and that, then is it truly sustainability? It's a really interesting part that you're right, does get overlooked a fair bit.
Yeah, exactly. One of the best things about that is, when you design for sustainability at the use phase, it's also, aside from the sustainability side, it's also the best to market because it's what's important to your customers and, what they care about, because it's saving them, money, saving them water, saving them energy, helps them really get to their sustainability goals. So it definitely has a benefit on top of sustainability. It also has a great story around it too.
No, and I'm sure some of the audience may have been coming in expecting us to go detail into, which products go into which, lead credit and this, that. I'll be honest, that would take a very dry presentation. But if you do need help with that, I would imagine Baz is certainly adept and happy to help.
We actually, sorry to interrupt, but really quick, we actually do have a lead product guide that goes over all of that on our website. We have a new sustainability website with all that, so I'll definitely love to send that link out. And it covers all the lead credit categories and how our products fit within it. Hopefully easy to read and digest, but I think it'd be a really helpful tool for that exact thing.
That's exactly where I was going. I saw that launch and I was gonna bring that up. If you go to watts.com, and I think it's either like /sustainability, but there's a big banner ad for it, I think. So that'll take you to that. Just check out the Watts website. And of course, along those lines, ATS also very committed to lead projects. We've done a lot of lead projects over the years. In fact, you'll find that we have our ATS templates, which is in essence, our masters, our regularly used fixtures based on application, which are available for all the engineers and architects to copy. If you are on atspec.com, you can use those and start building out your own version of that particular template. But we've got WaterSense labeled and LEED labeled versions of those templates. And we're actually working on integrating a new filter function that will allow anyone to just toggle the WaterSense and see all the WaterSense faucets and things like that. So we're certainly trying to align with to focus on sustainability as well. But no, it was fantastic. I haven't seen any questions coming in, so I guess with that, we won't really. We'll give everyone a little bit time back in their day. We appreciate you spending the hour with us here. I really learned a lot today about it. So it was fantastic, and it was nice to hear from you on the sustainability front. Maybe we'll do another one next year. If this is your first time on an ATS University, thank you for giving us a chance. Like we mentioned, there's a whole suite of others that are previously recorded, or you can reach out to me, zach@atspec.com, and we can help set up any of these as a lunch and learn for your firm. And of course, if you do need help getting set up for your firm on the ATS Spec tool, again, reach out to me, or I'll have my customer success team reach out to you. to get your setup, get your team members set up, and you can start efficiently selecting products on the spec tool and getting all your output formats as available. But yeah, that was fantastic, Bas. Thanks very much, and enjoy the rest of the day, y'all.
Yeah, thanks very much. Thanks everyone for taking the time to listen.
Bye for now.